Hi, I'm Rick from arcadetestprep.com, and today we're doing SAT Math Strategies. Feel free to print this document out, attempt these on your own, and then you can listen to the explanations here or follow along as we go. There is an additional document with a bunch more problems like these. You'd want to revisit at a later date, confirm you can still do them. So the more times you encounter a problem, the more concrete the strategies become in your mind. So definitely get that repetition in there. So number one, here's a right triangle. One angle is x. Here's sine of x. What is cos of 90 minus x? This is really the only trig identity they test, is knowing about this 90 minus x thing. So let's say we draw out the triangle. Here's x. Sine is opposite over hypotenuse. We don't need to get the other side, actually. If we have this triangle and a 90 and an x, what's this other angle up here in terms of x? Well, you do have to know the angles in a triangle add to 180. So up here is 180 minus 90 minus x, or 90 minus x. So really, they're just asking for the cos of this other angle. Cos is adjacent over hypotenuse, so the answer is the only number they give you, 5 over 13. So not a ton of work, just knowing that relationship. Anytime you see 90 minus x, you picture the other angle in the right triangle. Number two, p% of w is 4. Which expression represents w in terms of p? I'd probably plug in numbers to make it fastest. Anytime percents are involved, you want to try to get 100 in the mix. So we could make w 100. And then to make this statement true, p would be 4. You read it through, 4% of 100 is 4, that's true. So the question is, which expression represents w? Well, for us, w is 100. So the question becomes, which expression is 100? The last piece is you plug in the 4 for p in all the answers. And you see which one equals 100. As soon as you see it's not 100, you can just keep going through. When you plug in numbers, definitely be in the habit of checking the other answers, even if you find one that works, because on some problems there could be multiple answers that work for the number you use. But when you use another number, only one still works. So that's why it's C. So again, we're translating these problems with our own numbers. Number 3, 400 items are for sale at the beginning of the day. At the end of the day, you have t% less. Which expression represents the numbers at the end? So maybe we make t be 10. It's a nice and easy number. So at the end of the day, it's 10% less than the original. 10% of 400 is 40, so you subtract that out and you're left with 360. We now go to the answers. Which one is 360? And so you have to plug in the 10 for t. This one's going to be bigger than 400. This one's going to be way low. This one's going to be bigger than 400, so that's why it's A. So really, when you're plugging in these numbers, you don't need to know the exact value. You just need to know, is it 360 or not? And if it's not, you don't even have to calculate it. So yeah, that's answer choice A gets you to that value. So anytime you can get 100 involved, it makes some of these percent calculations super easy, which is nice. Number 4, 20 plants were planted. It increased by 150% each year. What's the number of plants t years after 2006? So you could memorize the exponential growth formula. It's not a huge deal to just derive it pretty quickly, but if we're going up by 150% each year, say you had 100, what's 150% of 100? Well, it's 150. So you add that to the original, and you get 250. That's the way most people do this in their mind. The alternative is, how could you get there directly just by multiplying? And it ends up that you multiply by 2.5. So straight away, it's got to be B or D. And then different ways to go. it turns out each year you want to times by 2.5, so the 2.5 needs to go with the t. The official exponential growth is that the amount at time t is the initial amount times 1 plus r over 100 to the t. Again, you could derive it for a situation pretty quickly, but that might help to know. Talking about spheres, the large has a diameter of 2x, the smaller has a diameter of x. What's the ratio of the volume of the larger to the volume of the smaller? So we're trying to figure out this ratio. Spheres have a volume of 4/3 pi r cubed. So it's going to be this ratio. We're not going to deal with the 4/3 and the pi's. Anytime you're comparing something, you only want to look at what's changing. I'd probably plug in numbers, make this small diameter 2, which will make the big one 4. So then when you go to do the radius, you have 4/3 pi times 2 cubed over 4/3 pi times 1 cubed. Again, do not put these in the calculator. It's just going to muddle things. So as you simplify further, you have 4/3 pi times 8 over 4/3 pi times 1. And then the 4/3 pi's cancel, you get 8 to 1. So anytime you're comparing, only try to focus in on the things that are changing. And this gets back to a concept from math or even science. If the length of any two things are in the ratio of 2 to 1, when you go to area, 2 dimensions, it's going to be 4 to 1. And when you go to volume, 3 dimensions, it'll be 8 to 1. So that principle is applied. Number 6, which of the following is equivalent to this? Always keep an eye on the answers to see how they want it to look. All the answers are fractional exponents, so that's our clue that we want to stay with fractional exponents. So that'll stay as part of the 3/5. Square root, we want to convert that to a fractional exponent. It's the 1/2 power. And then what do we do when we multiply? You add. So it becomes r to the 3/5 plus a half. You could get a common denominator and combine them, or just throw these in your calculator and you would get d. The sum of three numbers is 765. One number is 50% more than the sum of the other two. What's the value of x? So let's let the other two be y and z. We'll do the easy equation first. We know x plus y plus z equals 765. The other one's going to be a little tougher. X is 50% more than the sum of the other. So x is x equals. How do we get 50% more than something? Well, you could times it by 0.5 and add it back to the original, or in one step, just times by 1.5. Different ways to go from here. I think it's fastest to just use substitution. Plug the 1.5 y plus z in for x. So you get 1.5 y plus z plus y plus z equals 765. Now, if you treat y plus z as an entity, like a single thing, what happens when you have 1.5 of something plus 1 of it? Well, altogether, that's 2.5 of that thing. So you have 2.5 y plus z's equals 765. Oops. Divide out the 2.5 there, and you get 306. So y plus z is 306. And then plug that back into either one of these equations. Probably fastest to go here. Times that by 1.5 to get x, and you get that x is 459. So again, sometimes you will have too many unknowns for how many equations there are, and you can never get all the variables, but just treat those unknown things as kind of an entity, a single thing, and you can get through it. Number 8, we've got a survey. The mean is 120,000. The median is 145,000. What situation explains that difference? So you can always just try out examples. Let's say there are 3 houses and they're all 145,000. Well, now the mean and the median are the same. They're both 145. Let's say we move this one here lower. We make it 100. The median is still 145, but now the mean is going to be lower. Because when we add them up, divide by 3, this 100 drags it down. So in order to make the mean lower than the median, you're going to need a few homes that are much less than the rest of them. So again, simple examples, write things out, try things, even if you disprove something, that's going to help get to the answer. Number 9, here's this equation. We understand the test is very much a video game. It's not like real math in school. In school, they give you an equation. You're expected to know what everything means and solve for every last bit. On the test, sometimes you don't even care. You just have to move stuff around. So this is a textbook example. Blah, blah, blah. Look at the answers. They're all p equals. So if we can get the p by itself, we'll have an answer and be done. So if the wording of the problem ever seems confusing, feel free to go to the answers. If you can make that happen, then you know you did it right. So it's basically solve for p. I'd put the a over 1 and cross multiply, always be clearing fractions. Now what makes this tough is we have two p terms. Now just like any normal problem, you need when you're solving for something, you need all the terms that have that item in it together. So you minus the ap over. So now all the p terms are together, but they're not combining, which leads to this unusual step, which is factoring out the p. Very odd to factor out a variable, but you could do it if you needed to. And the last step, you divide by the 1 minus a. So always look at the answers for clues. You have a whole nother sheet of these to practice. These are some very representative SAT prep problems. Please like the video if you liked it. Subscribe if you want to see more content like this. If you want personalized prep and access to our entire programs, send me an email, and good luck.